Now let's look at a couple more options for providing input to our programs. But first, let's start with an example. So on Unix-like systems, Linux, Mac OS, or Unix itself, there's a program called cat. It can do several different things, but I would guess it's used primarily for viewing the contents of a file. So I say cat, give it the name of my file, string data.txt, and there's the 5 lines within that file. But how does cat know that this is the name of the file I want to read? We're going to see how this works now. So remember that main is a function, and it turns out that like other functions, we can provide input to the function. In this case, that input comes from what we call command line parameters. So I could give it the name of a file if that's what the program expects, but I'm not limited to that. There's programs where you wouldn't give it the name of a file, but you'd pass other things on the command line to it. All right? Regardless of how you're using it, this is a way to get that information to it. So what we have here are 2 variables, int argc, which is the number of things on the command line, and char star argv and then square brackets indicating that it's an array of addresses of characters. Sometimes you'll see this written instead as char star star argv, but it's doing the same thing. And like other functions, argc and argv are the variable names being used here. You could use something else if you wanted, but this is the convention and probably should stick to it unless you have a good reason not to, so other people reading the code can understand what they're looking at. So how's it used? If I ran this program and then have a space here, 1 or more spaces actually, and then something I want to pass to this program when it's running, then argc is 2, and the first thing that I've written on the command line here as a string is argv0, that's where it's stored, and the second thing is stored in argv1. If I give it 3 things, homework.exe, input.txt, output.txt, then argc is 3, and each of these 3 strings is associated with these addresses that are stored in this array. So let's see it in action. So I'm going to change my void to int argc char star argv square brackets. Let's print what argc is. So it's an int, as described right here, and I'm going to print that. And let's have a loop. Since I don't necessarily know how many command line parameters there be, that's why I had the variable I. We'll have a loop that goes through and prints each one. So it starts at 0. While I is less than argc, we'll keep going. And we'll print argv sub I. Each of those is a string. So now we compile, run it. Well, this time I didn't pass any additional things to it, so the one thing on the line was a.out, so argc is 1, which means here I have, while I is less than 1, do something, so we just printed that one thing, and then the loop stops because there's no additional things. Now if I did this, 1, 2, 3, 4, you can see argc is 5 because there's 5 things there, and then here's the 5 strings. One thing to be aware of is that even though you look at the 2 and the 4 and think, oh well, those are integers, they come in as strings. So it's as if I'd written, or in terms of how it's stored, is 2. Now if I tried to pass this, then it would have a string containing a string kind of thing. So it's really not stored this way, but this is what it thinks it has. So if I want to use the 2 or the 4 as part of a mathematical expression, I would need to convert those to integers. So if, for example, I knew my program was always going to pass in numbers, like that, then I could change it to something like this. Let's change that to sum. Sum equals 0. And let's also produce a sum along the way. So I'm going to print them as strings. I could convert them to integers first and do that. I'm just going to do this on the fly. Sum plus equal a to I. That's the function for converting strings that look like numbers, which are stored in ASCII, to their corresponding integers. A to F would be for floating point numbers. And I'm going to get R, V, I, but only if I is greater than or equal to 1, because I'm printing the initial A to I. So I need a conditional here. If R, V, or excuse me, if I is greater than or equal to 1, or greater than 0, I guess I should have said, then produce a sum. And also A to I is stored in standard lib, so I need that library. And the sum here should be 10, so let's see if we get that. There's our sum is 10. What would happen if I did this? Will still work. The way A to I is written is that it's going to return 0 if it can't turn this into an int. But I should be careful about doing things like that. All right? So that's one option. I could leave this here, but I don't want to make it misleading. There's another option as well. Let's use this. What if I don't want to hard code a particular file name to inside my code, or I don't want to pass in the file name using command line parameters? Well, there's another way to do it using what's called stdin. So let's do this. I need a buffer first, char buffer. And I'll assume a line of a file can be stored in 100 bytes. That's in its entirety. So while f gets string buffer, size of buffer. And then what do I use for the file pointer? Stdin. And notice that the color of this changed to indicate it knows it's something special, just like it does for standard IO. So why not equal null? We'll print the lines of a file, which will be stored individually in buffer. So how do I use it? You have to be careful here if you're doing something like this. So let's say I compile this, and let's say I run my program now like this. See, it's just hanging because I didn't use it correctly. So what I need to do is redirect the contents into the program. So let's use string.data again, and there's the content. So notice the less than symbol used here kind of looks like it's an arrow pointing to the left, so I'm saying in. Because I also could do something like this. I could do this for normal programs, not just in this case. But I can redirect the output to a file where it might be my output.txt. That doesn't exist. So if I look at my output, there's the contents. So I use this sometimes when I have a variance in file names and don't want to hard code them or do something else to jump through some hoops. In terms of the last thing I just showed you, let's say we did this. There's certainly plenty of times that I want to just print to the screen, but there's other times I want to save that output to a file for various reasons, because maybe it's easier to search or whatever. There's the screen, and now I'm going to redirect it to my output, and when I look at my output, I can do this. So maybe if I open it up in Vim, which is my editor of choice, and I say, well, I want to search for the line that contains 7, well, then I can easily do it here. Whereas if I have 1,000 lines, I don't have that option to easily do it from the command line. Meaning here I can look back at 7, but if there's 1,000 things here, it's easier just to save to a file and then search within that file. So those are a couple more options for getting input to files or saving the output from files. Notice here I didn't actually have to write anything to the file directly. I just redirected at the command line. So that's a useful option.